I'm Sanath. I'm an engineer on the AWS Serverless team. I started in the serverless organization about 3 years ago, and I was working in the backend infrastructure of AWS Lambda, which is one of the serverless services, but quickly found my passion with developer tools. I've always been an open source enthusiast and a contributor, and this sort of kind of all fall in place. Today, in the next 25 minutes, we're going to talk about a story of how we created open source communities around serverless developer tools. Adrian gave you a quick rundown on how we think about open source at AWS. We are obviously working with the community, helping grow the community by contributing a lot of code. We have open sourced hundreds of projects on GitHub in the last decade, and these projects range everything from SDKs to client-side tools. We also open source some of the foundational components of our AWS services, like Firecracker, for example. You're going to hear someone talk about Firecracker next. And we also open source OpenJDK. We have a flavor of that, and we have OpenDistro for Elasticsearch. We have a lot of open source code out there, and our employees are also encouraged to contribute back to the community. If you look at our GitHub repos, aws.github.io is a good starting point. You can find our documentation, which is open source. You can find a lot of reference architectures, a lot of sample apps, and examples. I'm here specifically to talk about how open source works with serverless. If that slide will show. Okay. By show of hands, how many of you know what serverless is? That's awesome. So this is going to be quick. Obviously, serverless services gives you no servers that you have to manage, and they scale as your load increases, and you just pay as you go. Serverless offers a lot of advantages over the traditional way of building a server application by basically taking a lot of the heavy lifting onto the services. If you think about the standard architecture of like a standard cloud app, there's a lot of business logic that you write for your API configuration, authentication, workflows, plumbing, and everything, which is usually written in your a traditional programming language, say Python, Java, or whatever. And then you have a little bit of configuration that provisions resources for you, say your databases, or probably it's a Terraform script, or a Puppet, or a Chef script to spin up instances, something that manages instances and maintains health for you, and all those things. In serverless, you still write business logic as code, but that's just a little bit, and that's exactly the business logic that you have to care about. Most of the plumbing work is now taken care of by AWS services for you. For example, API, user flows, and user authentication and workflows could be offloaded to AWS services like API Gateway, Cognito, or step functions. And all you do is write a simple configuration file that provisions these resources and tells the service how they have to behave, rather than writing code that explains how an API is set up over and over again. For every one of your application, you just configure the service and say, I need a highly available API service, and you need to provision me routes /foo/bar and respond to get and post. Done. And you obviously still have your configurations for your databases and other stuff. But what this creates is all the tools, your IDEs, your build systems, your code packaging and deployment tools that were dealing with a lot of code now has to start working with all these configuration files that you create. This created a great opportunity for a whole lot of developer tools to be born in the serverless space. And guess what? Almost all of them were open source. I'm going to highlight a few of the ones that's on the slide here. Serverless Framework was, I think, one of the first developer tools that was created, and it's definitely by far the more popular one, going by GitHub stats. They have 30,000 stars on GitHub, and Wow. I don't know why this is. Yeah, I'll keep. Yeah, they have over 30,000 stars on GitHub, and I think they have over 500 contributors. Architect is a simple DSL that you write to define your serverless applications. Apex helps you manage Lambda functions. Sparta lets you write Golang code to provision resources in the cloud. Plumi is similar, but with multiple languages. Claudia and Zappa are JavaScript and Python frameworks to provision serverless applications. From AWS, we have AWS SAM. Whew, that's the tool that I work on. We obviously we open sourced it in we released this in 2016. We have Chalice. I'm going to talk a little bit more about these tools: Serverless Express, Serverless Java Container, and Amplify. And SAM is a tool that I work on, and is a journey that I'm most personally familiar with. SAM has 2 GitHub repositories. It has an active community on Slack with over 1,800 members in it. And it has over 100 contributors that have contributed to code, documentation, and issues and everything. SAM is integrated into serverless application repository, so you can write your serverless applications and share it with others, and you can also make them public on the repository for others to consume. And most of the public ones are open source with the code available on GitHub as well. So if you want to quickly get started, you can just go to the repo, download an application, get the source code, start hacking. Amplify is another open source tool that helps you build web and mobile backends with serverless technologies. Chalice is a Python microservice framework. They GA'd last year, and it's pretty fast and simple to take a Flask Python application and then deploy it to serverless. Serverless Express lets you run Express.js applications on Lambda without modifications. Serverless Java Containers is a similar Java wrapper for like Spring and other Java frameworks. All of these tools have a vibrant ecosystem of developers working with AWS to contribute code and software. How did this all come about? I don't know. I'm not quite familiar with all of the other projects, but the one that I'm most familiar with is SAM. So let's talk about the journey that we went through to basically starting to think about SAM and then releasing it and eventually open sourcing it and how we build a community around it. But first, meet SAM. That's the little squirrel that takes a infrastructure configuration defined in like a JSON or a YAML file and provisions the application for you. It has another squirrel that knows how to type on laptops and wears a glass. It all started with a open specification that we put out on GitHub called Serverless Application Model, and we invited the community to contribute their thought and ideas on how to build a serverless application. And that's all it was. It was a specification inviting people to contribute to a model that we can use to express serverless applications, to contribute the development workflow that we want, the ideal development workflow that we want to build for serverless, and it was all collaborative. This was super cool, and there was a lot of buzz and activity around it, around the repo. Even after just a couple of days, people had brilliant ideas on how to improve the model, the specification, and the way this worked was we put out the specification, but the reference implementation was still internal, and we made that available to customers as a service to use, so they can write their serverless applications using the model and send it to the AWS API, and it'll go deploy it and run it for customers. So while people were contributing their thought leadership, we were busy implementing their contributions back as source code. And in a couple of months after we released, someone got an issue saying, hey, why don't you actually open source this? Because it's all cool that I'm able to contribute to ideas, but I really want to get down to the details and start hacking code. Even before this issue was cut, I was exploring internally, talking to people in my team about how we can actually open source SAM. The first question is obviously, is it even possible to open source? Thank you. SAM is a service. It is available and deployed to 15 plus AWS regions at this point. It is integrated into other services like Serverless Application Repository. And there were questions from the team on, what if someone just stole our secrets to us? And these are valid questions, right? Like, what if someone just added malicious code? And we being at OSCON know how all these things are tackled by the open source community, but when you don't have an open source product, and the product is already behind closed doors, and we have a notion of how security works, how safety works, this is all questions that we have to answer. What if someone just wrote poor quality code? And this was one of my engineers talking about code quality and how can we make sure our code that people contribute is really, really good quality code? How can we even teach the community on how to write code? Should we even teach the community? And the questions also twisted around, can we actually run an open source product as a service? At this point, we had Amazon EKS, which runs the Kubernetes code, and we had EMR, which runs Hadoop, all of them as services, and they take open source code and run them as services. But in our case, we were exclusively offering SAM as a service, and these had other management layers built on top of it. So pretty much all of the service would be open source if you open source SAM. And how can we actually keep some features secret because we want to announce a big bang at a conference like reInvent, for example. And this was the best one. I love this question. Do we have the right team to manage an open source project? And I could answer almost every one of those previous questions, but I basically had no idea if we had the right team to manage open source projects. And so we wrote a PR FAQ, which is an internal document that we write, working backwards from the customer and what we want to release, and explaining all the data points on why it's a good idea to open source SAM. And after we finished writing the document, it was apparent to us that the document was all about how to run a open source project. It was not convincing anybody on why open sourcing is a good idea. It was just explaining how to run an open source project and how to build a community. And that's when we realized we had to build a community first, and software just happens. We realized that if we build a vibrant community around SAM, we can combine the agility of open source development with the quality assurance practices that AWS has, and build high quality software. And so we eventually open sourced SAM in 2018 April. This is when the implementation was open source, and then we subsequently also released other products and tools around SAM that ended up being open source as well. In this process, we had to build a team. Kind of going back to my previous slide on how I did not know how to build a team that can manage open source projects, we thought, what would be an ideal team to build an open source project? And the team should be obviously not only have AWS engineers in them, it should have community developers as well. So we created a Slack channel. It has over 1,800 people right now, and a lot of activity and contribution talks and stuff. This is where our engineers hang out, and the community hangs out and talks about what problems they have, help each other out, talk about new features, how we can improve the product overall, and stuff like that. We also, when we have this one team that is all open, that is all talking out in the open, we also externalize all of our development processes. So we don't use any of the internal tools anymore. All of our software is exactly the same software and stack that the community developer uses. So we can all feel together as one team. We do pull requests out in the open. We do code reviews out in the open. There was an email thread internally a few weeks ago on how harsh we can be on the pull requests and pull requests out, because we have pretty high code standards internally, and we're pretty straightforward and blunt when we come to feedback. And we realize that the same thing applies to the community as well, because everybody wants to learn how to write good quality software, and we want to learn from each other. And so we have a we don't have any bimodality in how we treat pull requests from internal versus external people. It's all the same. All our releases are in the open, and so it was all super fun. Once our development practices were in the open, we realized that our product decisions were still being made internally. So we open sourced. We opened up our product decisions using a request for comments process, so where community can. We'll have ideas posted out in the RFCs, and community can upvote and provide feedback. We communicate priorities of different tasks and items with labels, and we also label tasks that are waiting for release, so community knows when it's exactly going to happen. And this basically made the whole process, both internal, both software development and product development, transparent to the community. My favorite part with open source at AWS is the automation that AWS brings in to open source projects. So while the community contributes code and thought leadership, we take that contribution and deploy it as a service behind the scenes. So this includes applying all of the best practices that we have learned by building services over the years, like safe deployments, automatic rollbacks, and alarming. We do security reviews on every release. We do two approvals on every pull request. We take care of deployment failures and rollbacks on behalf of the community. We do public design discussions and everything. So this is where I started to understand how the whole AWS open source ecosystem works. It's not only the community contributing code, but AWS adding a lot of value by taking our development practices and bringing it out in the open. Internally, we also have a weekly review of community, business, and product health, and these are some of the metrics that we review during these meetings. We actually, wow.
Well, it's okay on that side.
Huh. Yeah, we review all these metrics internally, and we actually publish them across the broader serverless organization. We also, trade notes. This is a practice that we do across AWS with different tools, different teams. So we also trade notes between other open source projects, so we don't repeat our own mistakes. This has created an incredible community that I'm super proud of to being a part of. Hundreds of contributors have contributed a lot of features. Some of them have been deeply involved. I remember one contributor, this was his first contribution, but he was a passionate .NET developer. So he spent a few weeks kind of hacking together how the same feature could be implemented in different ways. And the first few ideas were super complicated, and he ended up with a really simple and neat, elegant solution. And this wouldn't be possible without the community support. Thank you.